digital art. Okay, that's awesome. Positivity, games, Instagram. Okay, sleep, editing. You're an editor on, what is that? Like, what type of editing? Is it like writing, videography, what type of, or photo editing? That's so cool. Video editing. That's so cool. I still love video editing. I used to really love it, but yeah, that's so cool. Anybody else? That is awesome. Okay, I'm going to go ahead and send the slides over. You can click on this link to follow along with the slides today. Did I send it? Okay. Nate said finishing school, sports, exercise, going to church. I love it. Okay, so you can click on those slides, and also you can save them because sometimes those slides do help you, you know, whenever you're going through it for a test or something. Perfect. But I am so happy you guys are here. Just so y'all know, I'm super happy y'all are here. I really love Wednesdays. They're like so fun for me to get to like see you guys. Also, I love the memes that y'all sent in because I sent out that text. I haven't been able to look at all of your memes yet. So some of you guys will be featured next week because your memes were awesome. But like I sent out a text and I said, send reply with a meme if you got this message. And I got a lot of really funny ones. So feel free to still send over a chemistry meme if you want to. You can text it to me or email it to me. But I didn't get a chance to look through all of them yet because it was like right before live class. So just know I'm really excited to look through those this week. But this was one that I got yesterday. I thought it was funny. Okay, so we're going to go ahead and get started. Reminder, some of y'all have started this week. Some of y'all, this Monday was your first. So welcome, and please fill out this form if you have not yet. It really is helpful for me if you, like, just to get to know you, or if there's anything specific about you. It helps me to like remember, because when you have a lot of students, I want to be able to remember each student. So whenever you fill out this form, it helps me have like a place for you in my mind a little bit more, and to just like get to know you a little bit more. And that's really helpful for me so that I can like remember things about you. Yes. Okay. And okay, so fill this getting to know you form. If you're new as of this week, or if you haven't done it yet, I would really love that. And let's talk about what we learned last week, because we kind of learned a lot of information last week. So last week we learned about significant digits, which is what the meme was about. Like, what are significant digits? So we learned that in every measurement that you've ever received, if any sort of measurement at all, the last digit is always estimated. So even if it's a an electronic tool, whatever the last digit is actually an estimated digit. It could be a 4, it could actually be a 5. It's like an approximation of what we think it is. And we learn about significant digits in order to learn how to round. So let's do some quick practice. Here are the rules up here again. So if you need a reminder about significant digits, how many significant digits are in this number right here? What do y'all think? I'm seeing a lot of 2s, right? The 1 and the 2 are both significant. Great job. All right. How many significant figures are in this number? 1. Great job. Okay. And if you're new and this is overwhelming to you, it's okay. You may get to this in just a little bit. You may not have learned this already yet. So try to follow along and it'll help you when you get to this lesson. So yeah, the trailing zeros don't count here. So only the 7 is significant. There's only 1 significant digit. How many significant digits here? What do y'all think? All right. All right. Okay. Okay. So leading zeros do not count. So these 3 zeros don't count. And the trailing 0 does count, because trailing zeros count when a decimal is present. Hey, Autumn, I'm glad you made it. Okay, so there are 3 significant digits there. Great job. I know, tears, right? Tears of joy for significant figures. Okay, last one. How many significant digits here? 5. Great job, because these sandwich zeros do count. So there should be 5 significant digits there. Great job. Okay. Oh, I accidentally showed the answer there. A million has 1 significant digit. And then we also learned, like, if there's a bar above it, what does that mean? How many significant digits are there if there's a bar above that last 0? It means that they all count, right? So if you put a bar above a 0, it means that all of the zeros up to that point count. So there would be 7 there if you count 1, 2, 3, 4, 5, 6, 7. Okay, so great job on that. Oh, sorry, Thomas, didn't mean to, if I'm talking too loud. Okay, practice rounding to the nearest tens place. So if you have the number 12.57 and you need to drop it off and get to the tens, what should it become? Okay, close. Not the tenths with the TH, the tens, like the tens place. And so this either needs to become 10 or 20 because we're rounding 12.57 to the nearest tens place. So great job. This would become 10 if we're rounding to the tens place, right? What about this number here? What if we're rounding to the tens place? What do y'all think? So, okay. So if we're rounding to the tens, this would either need to be 1,110 or 1,120, right? Because that 3 is in between the 10 and the 20, right? So this would become 1,110 because that 3 is closer. It's only 3 away from the 10 and it's 7 away from the 20, right? Okay, so those were those two. Now we're going to try it one more time. Round to the nearest tenths with the TH now. Round this to the nearest tenths place. Great job, saying you got it. Okay, so the tenths place is the first one, not the second decimal, which is kind of confusing. You might think the first one is like the once place, but there is no once place. It's just tenths. And so this is either going to become 12.5 or 12.6, right? So it's going to become 12.6. Great job, Lincoln. Great job, Aisha, Catherine. Y'all are doing great. Okay, what about this one? How would we round that to the nearest tenths place? Y'all are doing so great. Remember, the tenths place is that first decimal, right? So it either needs to be 0.1 or 0.2. So we're just going to leave it at 0.1 because the following number is just a 0, right? Is this kind of making sense for y'all? I just wanted to do a quick recap. That was confusing for some of y'all, and that totally makes sense if this is a little bit overwhelming. And you can always come to me and I'll go through it more slowly with you if you need help. So for this week, we're going to learn about some more fun stuff. By the end of this lesson, you should be able to convert to scientific notation. By the way, here are the slides if you came in late. Here's a link if you want to click on it. You should be able to convert from one unit to another. Convert from one unit to another. And those are the main two things we're going to learn. We're going to simplify it so that we're not overwhelmed, okay? So this is going to prepare you for your Unit 1 test. It's going to prepare you for some of your quizzes from Unit 1, and it's going to prepare you for some of your lessons from Unit 1. So it's kind of all-encompassing for within Unit 1. But it also pertains, I think, to outside of Unit 1 as well. In the following units, there are lots of conversions. And so whenever I do a subject, I make sure to kind of make it to where everybody can benefit from it, depending on where you are. Okay, so how many atoms are in a grain of salt? What do y'all think? Any estimation there? How many atoms do you think are in a grain of salt? You're like, I have no idea. A lot of them, right? It's going to be a big number. How many atoms do you think are in one grain? We're talking about when you pour out like some salt, 1 grain of salt, a lot. Somebody looked ahead. Great job, Catherine. This is how many atoms are in 1 grain of salt, roughly, okay? That is a lot of zeros. Does anybody know what that number would even be? I don't, and I don't want to know. I don't really know all of the numbers after, I guess, a trillion. It gets kind of fuzzy to me. What do you guys think the length of a human skin cell is? So a skin cell, that's a little bit bigger. A cell is actually bigger than an atom. Megan's looking ahead here, right? The length of a human skin cell is 0.00003 meters, okay? So sometimes in chemistry, you can see we have huge numbers, like the top one, and we have small numbers, like the bottom. They both have a lot of zeros, but the first one is really huge. The second one is really, really, really small, right? So when we have a big, big number, something that we can do to make it easier to process would be to shift the decimal place. So let's start this over again. Hold on, it'll restart. So we can shift that decimal and count how many times we shift it. You see how we're counting here, counting. We get all the way over, and finally we get there, and we can rewrite it like this, okay? So that's how scientific notation kind of works, and we're gonna break it down whenever I do some practice, but you can watch it one more time. That 18 becomes the exponent on top, okay? I think I also did the GIF for this one as well. Hold on, let's see if we can do it here. Okay, so you can see here, I'm shifting it over and then rewriting it that way. But when you're shifting it this way and you're shifting it to the right, you see that there's a negative sign in the exponent. So you count how many times you shift it over, and then that goes in the exponent on top, but it's a negative this time. So we're gonna talk about why. We're gonna do some practice with it, so don't feel overwhelmed about it. But this is how scientific notation works. It's actually really nice whenever you're dealing with really small and really big numbers. So if the number is larger than 1, if the number is a big number, you're going to shift that decimal point to the left until there is only 1 digit left. And then you count how many times you shifted, and you use that as the exponent. So for example, in 123,000, you would shift the decimal from right here where it is all the way over to the 1. So you stop once you get to the smallest whole number that you can, right? So it's going to become 1.23, and you count how many times you shifted it. Well, we shifted it 5 times, and so it's going to become 1.23 times 10 to the power of 5. That 10 will always be 10. You never change the 10 part. It's the exponent up here that you change sometimes. Looking at this example here, if you have 5,600,000, you can shift it all the way over until you get to the smallest whole number possible. So that would be 5.6. And this time we shifted it 6 times, and so it's times 10 to the power of 6, okay? When you have a small number, we're gonna shift it the opposite way and add on a negative sign. So for example, 0.000206, that is a number that's smaller than 1. It's a decimal number. So when you have a decimal number and you're shifting to the right, you're going to put a negative sign up here. So we're going to count how many times we shift until we get to a whole number, and then put a negative sign on top. Here's another example here. We're going to shift it over until we get to a whole number, count how many times we shifted, and put that on top. Is this kind of making sense to y'all? Or is there a part where you're like, I don't really understand at this point? Kind of want to see this making sense. Okay, we're going to do some practice on a Jamboard so that you guys can also have it there. So you can click on this link to go over to my Jamboard here. You're going to see some problems like this throughout your Buzz lessons. Let me share the Jamboard link in case I haven't yet. Yeah, here it is. Okay, so here's the Jamboard link in the chat. Okay, Catherine, that's a great question. We'll go through that together. So you're going to see some questions like this, and it'll say, perform the following operation, write your answer in scientific notation with the correct number of significant digits. So you have 2 options here. 2 options. Option 1, you can put this in the calculator the way that it is. You can put it in your calculator exactly that way, right? You just have to make sure to count your zeros the right way. So I have to count how many sets of zeros. There are 1, 2, 3 sets. I'm kind of in my mind, remembering that. And then I can go over to my calculator. And I've got to remember all the zeros. That's kind of annoying to do, right? You have to count out all the zeros. And then we would do it for this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I think I did that right. And you could subtract, and then you would get this number right here. I'm using Desmos. Everybody click on this link if you haven't and bookmark it, because, or I think you need to do a control click so that you don't leave the meeting if you do control click. But this is a great scientific calculator. And so I've gone ahead and subtracted, and I'm getting my number, 7.2 times 10 to the 9th. Okay, now we're going to do it the other way. We're going to do it by converting first. So this is option 1, just put in the calculator that way. Option 2 is convert to scientific notation first. So y'all help me out here, or try to work with me here. So we have the invisible decimal is right here, and we're going to shift it all the way over until we get to right here, right? because that would be the smallest whole number. So I'm going to count how many times I shift it over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to become 1.2 times 10 to the power of 10. I'm sorry, 1.26. I don't want to leave off that 6 there. Times 10 to the power of 10 minus, and then I'm going to do this one over here. So here's my invisible decimal. I'm going to shift it all the way over until I get to here. So I'm going to count how many times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 5.4 times 10 to the power of 9. And I can put it in my calculator that way, like this. 1.26 times 10 to the power of 10 minus, and then I like to do parentheses just to make sure, because sometimes the calculator can get confused. There are shortcuts on your keyboard to like do an exponent, but if you're trying to do an exponent, you can click this, like if you're trying to do an exponent, you click this A-B button right here and it puts it in an exponent like that. And look, do you see how these numbers are the same? So you can do it the top way or the bottom way. The top way is where you just plug it all in. The bottom way is where you put it in scientific notation first. And sometimes one way works better than the other. But we need to now put this in the right number of significant digits. So how many significant digits does this number have right here? How many significant digits does the first number have? 3. Okay, this one's got 3 significant digits. All of those trailing zeros do not count. Okay, how many significant digits does this one have right here? 2, right? These 2 right here, all of the trailing zeros do not count. If that's confusing to you, don't worry, just come talk with me about it and I will make it less confusing for you. So we have to go by the lowest one. So we have to go by 2. We're limited by the 2. And so our final answer can also only have 2 significant digits. And so I'm going to double check. We've got 1, 2. So this is my answer. I'm good to go on this one. Okay. Now we're going to try the smaller one, and this is what some people get confused with. So I'm going to show y'all how I would shift it, okay? So y'all watch carefully if you were confused about the negative sign. This is a number that's a decimal number, right? If you have a big number, it's going to be a positive exponent. If you have a decimal number, it's going to be a negative exponent. So now we're shifting the decimal to the right, okay? I'm going to shift it all the way over to right here for this one, and right here for this one, because you're trying to get to the smallest whole number, right? And I'm going to just count how many times I shifted. 1, 2, 3, 4, 5, 6, 7. So it's going to become 5.6 times 10 to the negative 7th, because it's a decimal, okay? And then for this one, 1, 2, 3, 4, 5, 6. 4.09 times 10 to the negative 6th. Does that make sense for the negative sign there? Y'all let me know yes or no if it makes sense with the negative exponent. I'm so glad I made it easier for you. Sometimes it's just stressful to learn on your own. Okay, so now we're going to put it in the calculator. I love this calculator, y'all, because you can do these shortcuts. Like the time sign is like the star above the 8 on your keyboard. So instead of like typing times, I can just do the star sign. And then if you want an exponent, you do like, y'all look at the chat, that is the exponent. So like if you want a shortcut for exponent, you can type in that instead, and you don't have to like do all the work for it. It makes things super quick whenever you're using this all the time. And then what was this, 4.09? 4.09 times 10 to the, 10 to the negative 6. Hopefully I'm doing this right, because when I'm multitasking, it's kind of hard. Okay, so we got a negative number here, but that's okay. 5.6 minus 4.09. Did I do that right? I did that right. Yeah. So it's negative 3.53 times 10 to the negative 6. Okay, but I have to match my significant digits. This one has how many significant digits here? How many significant digits on this one? Leading zeros do not count. Thank you. Yes, 2. How many significant digits are here? 3. Great job. So we've got to go by the lowest one. We've got to go by this one. So we can only have 2. So I like to underline, I can only keep the 3 and the 5. So then when you only can keep those 2, because we have to match this one, to match the lowest one, I've got to drop off this 3. So should this become negative 3.5 or negative 3.6? What do y'all think? When I drop off that 3, should it become negative 3.5 or negative 3.6? Great job. Thank you, Sang. Thank you, Leanna. Okay, I want to make sure that makes sense. It's going to be negative 3.5 because that 3 is closer to a 5 than it is to the 6. Like, it's only 3 away from the 5. It's 7 away from the 6. If this number is 5 or higher, it bumps it up. But it's only a 3, so we're going to leave it the way it is. So those are my 2 examples there. I'm going to switch back. Hopefully that kind of helped y'all with scientific notation. We only have time for a little bit of metric conversions. If you need more help with it, then I would love to help you later with it as well. But we're going to do a little bit of it now. So there's a lot of ways to represent a dollar, right? You could say 100 cents, 10 dimes, 20 nickels, a tenth of a $10 bill, 4 quarters. There's like a lot of ways to represent $1. And in the same way, there are a lot of units that represent the same thing. Like, that's why we need dimensional analysis, okay? So there's a lot of ways to represent a dollar. In the same way, there's a lot of units. And so we need to know how to convert between them. So when you have a relationship, you can put it in a fraction, like 4 quarters over $1 or $1 over 4 quarters, right? And we're going to do that when we do this here. Hold on. I'm going to kind of skip this and just show you my steps, but you can slow down and look at this and see if it kind of makes sense to you. I'm doing it here again. See, I'm just making them into fractions. But here are the steps for dimensional analysis. And we're going to start by just doing a problem here. So when you're converting things, you always write down what you're starting with, and then you put it over 1, and then you're going to multiply, put the unit you're trying to convert to on top, and then what you're trying to cancel out on bottom. So for example, if you have 18 quarters, and I'm asking you, how many dollars do you have if you have 18 quarters? Some of you will be able to do that in your head, but let's pretend like it's a complicated thing and you're like, I don't actually know. Like, I do conversions like this all the time. I was actually trying to figure out how much money it would take to make homemade ice cream. And I did like all the conversions to compare with Bluebell ice cream. And I was like, oh, I'm going to save money. So I love to make homemade ice cream. So you do conversions like this actually all the time. So you're going to write down what you start with, and then you're going to put it over the number 1. And then you're going to multiply, do a fraction line, and you're going to put the unit you want to get to on top and the unit you want to cancel out on bottom. So see, we want quarters to cancel out. So see how they're going to cancel out because 1 is on top and 1 is on bottom. And then you're going to put in the relationship. You think, or you can Google how many quarters are in $1, and Google will tell you there are 4 quarters in $1. And then you're going to put the number 4 with the quarter and the number 1 with the dollar, because it says that there are 4 quarters for every $1. Does that kind of make sense, that process? You write down what you start with, you multiply, you put the unit you want to get to on top and the unit you want to cancel out on bottom, and then you put in the number relationship, like there's 4 quarters for every $1. And so you put that in where the fraction line is, and then you just calculate it. So you can put this into your calculator. You're doing 18 times 1 over 4, or 18 divided by 4, and you should get $4.5 out of that. Does that process kind of make sense to you guys? Y'all are doing so great. We're going to do one more quick example here. Miss Becca measured the air in her tires to be 2.14 atmospheres. How much pressure is this in units of pascals? So what should I do first? What's the first step when I'm converting something? Y'all are doing so great. What should I do first here? Some of y'all who have already done this, I know that y'all know this. I've worked with a lot of y'all on this before. Great job saying, yes, we're going to write down what we start with, which is 2.14, and we're going to put it underneath the number 1. So you write down what you start with and you put it over 1. Yeah, or you can write down like everything and just like get started on it. And then we're going to multiply and do another fraction line. And what are we going to do now? We're going to put the unit we want to get to on top and the unit we want to cancel out on bottom. Piper is saying we should cancel out the atmospheres. That's great. And what unit are we trying to get to here? Yes, great job. Okay, I'm seeing that. Great job, Myra. Y'all are on top of it. We're trying to get to pascals and we're trying to get atmospheres to go away. So that goes on top and the other one goes on bottom so that the atmospheres cancel out. And then here's the key fact. You need to go Google, on Google. You can try right now if you want to on a different tab. How many PA in an ATM? Like how many pascals in an atmosphere? And Google should tell you the answer on that. Google search how many pascals in an atmosphere. And Google should tell you this right here. And you can double check me on that there are 100,000 pascals in an atmosphere. So should we put the 100,000 on top or on bottom? On top, because the 100,000 is going to go with the PA. It's going to go with whatever unit it's with. So the 100,000 goes on top and the 1 goes on bottom. And now we just multiply. The numbers on the bottom are only the number 1, so they're not going to really impact your numbers. So you could just multiply on top, or you can put in the entire fraction if you want to be careful. I was always super careful and I wanted to do it exactly right. It's totally up to you, but you should get 214,000 pascals. So we're going to stop here. If this does not make sense, please stay back. Or if you want to work on this lesson, like if you're working on lesson, I think this is from lesson 4, you can stay back and we can work through it together. But I hope you guys have a great week. Remember that we're off on Friday and on Monday. So I won't be in my office on Friday or on Monday. You're welcome to continue working, but we won't be here. Like teachers won't be here. Bye guys. Y'all have a great day. Y'all can hang out if you have any questions. Bye, Adam. Bye, Lincoln.